Okay, guys, so the very last part of 8.2. So this is still, make sure it focuses here. Okay, this is still for April 6th, part B. We're going to do one last thing, 3 examples. We're going to express a number as a ratio of integers. Fancy way, ratio of integers, to say fraction. Okay, so we're going to write the number as a fraction. Okay, and we're going to start with 0.8 repeating. Okay, so first of all, let's just talk about, do we remember what that means? We haven't done stuff like this for a long time. So 0.8 repeating means we've got 0.8 and it repeats, right? 8 repeats. Okay, dot, dot, dot. Okay, so what we're going to do is we're going to write this as a sum. We're just going to work this backwards. So this would actually be 0.8 plus, now I want this one in the hundredths column, so 0.08. And then plus 0.008, and you get the idea, right? 1, 2, 3, 8, right? If we keep going, that would give us 0.8 repeating, okay? So now we got to figure out how to kind of write this as a rule. And the nice thing is once you see the pattern, it's always the same, okay? So this guy is going to be 0.8. This is going to be 0.8, but times 0.1. Okay. This guy here, there's 2 ways we can write it. Let's see if we can go right to, this is going to be 0.8, and then this is going to be 0.1, but squared, because this would actually give us 0.01. Take it times 0.8, and we get 0.001. Okay, plus, this is 0.8, and this would be 0.1 to the third, okay? This only gives us 0.001, but then we take it times 0.8, which moves the 8 all the way to the 4th place. Okay, and if you want to play around with your calculator, you can to kind of see how that works. But the pattern is if one number is repeating, so 8 is repeating, this is always going to be 0.1. Okay, if you, like I said, if you want to type it in and kind of check this stuff, you could actually do that. Okay, so now we're working backwards, and we're going to write this, it should be okay, as a summation, n equals 1 to infinity. And, look at my sheet here, all of these repeating numbers are all geometric series. Okay, so, all right, so we'll come back to that. Let's make sure it stays focused. Okay, so what else do we want to do? Okay, so let's do this guy. This is a sub 1, this is a sub 2, this is a sub 3, this is a sub 4. Okay, so what's the relationship? The 0.8 is always there, so that's not going anywhere. And then I have this 0.1, but if this is a 4, this is a 3. This is a 3, this is a 2. 2 is a 1, and even better, 1 is a 0, right? I don't have 0.1 at all there, because 0.1 to the 0 power is just 1, and so I don't need it. And so this is n minus, n minus 1. Sorry, that's important. N minus 1. Okay, and that is my geometric series. If I can write it correctly, right? 1 to infinity, a r to the n minus 1. Okay, and if, oh my word, I showed this in the last section too. This shouldn't say a. What should this say, guys? Shoot, we're gonna have to change that into the last section. This should say r. Oh my goodness, I tell you, that should say r. Sorry about that. Make sure if you copied that down in part A, make sure that we go back and change that. That should say r. I'll type that in the email too. I apologize for that. If r is less than 1, then it converges, and it converges to a over 1 minus r. Okay, so this is my a, and this is my r. And my r, sure enough, my r is less than 1, so it converges. And it converges to a over 1 minus r. So a is 0.8, and then r, so 1 minus 0.1. So what does that give us? 0.8 over 0.9, which takes us to 8/9. Okay. So here we're just kind of using this geometric sequence, and guess what? If you do 8 divided by 9, you better get 0.8 repeating. Okay. All right, let's try another one. We've got 2 more. Same thing, we're going to express the number as a, they like to say ratio of integers, which is nothing more than a fraction. Okay, all right, let's try. All right, so let's try what happens if it's 0.46 repeating. So what happens if 2 numbers are repeating? 0.46, then 46, 46, 46, dot, dot, dot. Okay. All right, so we just have to see the pattern. Once we see the pattern, it's always the same. Make sure you guys can see it for 2 numbers repeating. So this would be 0.46 plus 0.00, that's these guys, and then a 46, plus 1, 2, 3, 4 zeros, because that's those guys, and then the 46. Okay, we get the idea. 1, 2, 3, 4, 5, 6, and then the next 4, 6, and then plus dot, dot, dot. Okay, can we see? Okay. All right. Oh, no, now my camera. Okay, there it goes. My camera. All right. Okay, so what do we want to do? This guy here is 0.46. This guy here, another way now just to write this, is 0.46 and times 0.01. Okay. All right, what is this guy going to be? This guy's going to be 0.46 and then 0.01 squared. So that would give me those 4 zeros, and then we've got the 0.46. All right, plus this would be 0.46, and then this would be 0.01 to the third. Okay, and then we get the idea, plus dot, dot, dot. So if 2 numbers are repeating, it's always 0.01. If 2 numbers are repeating, then it's 0.01 in there, always. Okay, so now let's work backwards. The summation of n equals 1 to infinity. This is a sub or 1, right? This is a sub 2. Oh my goodness. This is a sub 3. This is a sub 4. Okay, so I always have the 0.46. That's not going anywhere. Okay, and then I always have the 0.01, 1 less. Okay, and that's the only time I don't have it here is because it's to the 0 power, which equals 1. So this is n minus 1. Remember, if these guys match, then we could write geometric. Okay, we're not really proving anything here. We're just finding something. But so this is geometric. This is my A, and this is my R, okay? And let's look at the corrected version again. It won't hurt to see that this should be R. If R is less than 1, then it converges, okay? So it definitely converges, and it converges to A over 1 minus R. So 0.46 over 1 minus 0.01. So 0.46 over that would be what, 99, and so we get 46 over 99. Should we try it? 46 divided by 99, maybe that would help if I showed you. 46 divided by 99, and there it is. Okay. All right, let's do one more real quick. 3.780, and that's what's repeating. Okay, so let's just write what that is. Oh, okay, let's make sure my camera, is my camera okay, guys? I'm kind of far away. No, come on, buddy. Okay. Let's make sure that that looks okay. All right. Maybe I'll watch this one. See now, okay. All right, I know it kind of goes in and out to begin with, but all right, so this is 3.780780. Don't let the 0, I'm just going to bring it along as any other number, and eventually we can drop it off. Okay, so what's repeating here? 3 numbers, okay? So the 3 is just going to come on the outside. Don't worry about that. So it's going to be 3 plus, and then it's going to be 0.780 plus 0.78, and like I said, I'm just going to bring the 0 along, 0.078, 0.001. Okay, and then plus 0.780, and then it would be 0.001 squared. Okay, let's see, we can sneak one more on here, 0.780, and then 0.001 to the third. Okay. Okay, so that if three numbers are repeating, then this is 0.001. Okay. Okay, so then the 3's out there, we're good. The summation from n equals 1 to infinity. This is what? A sub 1, this is A sub 2, A sub 3, A sub 4. Same thing, right? They're always one less. It doesn't exist here because it's one less, which would take it to the 0. So 0.78, and again, if you just want to tag along the 0, that's fine. And then it's 0.001 to the n minus 1. Okay, we're in good shape. Those two, remember, those two have to match, but we're in good shape. This then is geometric. This is A, and this is R. Okay, R is definitely less than 1, so it does converge to A over 1 minus R. A is 0.78, and again, if you want to drop the 0, that's fine. If you just want to keep it along, that's fine. 1 minus 0.001. That takes us to what? We're 0.780 over 0.999. Actually, you kind of need the 0 anyways, but if you drop it, it would just come back. So that gives us, we can move the decimal 3 places this way, 3 places that way. Maybe I should have done that. So 780 over 999. And then if we want to write it as a mixed number, right, don't forget your 3. Okay. Otherwise, you might go to the calculator. At that point, you could type that in if you wanted, or you could get a common denominator and do it on your own if you wanted. It should be 1,259 over 333. So there's a little bit of reducing there. Let's check. 1259 divided by 333, and there it is. Okay, this just rounded, right? That last one just rounded it. Okay. So, yeah, maybe, are we okay? Maybe, did I go too quick? Are we okay that 0.46, you would move the decimal 2 places? You can, as long as whatever you move on top, you have to move on the bottom, which in this case balances nicely. Where's that other one? And 0.8, hopefully it doesn't go crazy. I would move it 1 place and 1 place, which would give you 8/9. Okay. If you want, I mean, I guess if you wanted to type this into your calculator, 0.8 divided by 0.9, and then just do math fraction, that would be okay as well. Same thing here. If you wanted to do 0.46 divided by 0.99 and then math fraction, that's okay. All right, at this point here, I'd probably type that in. And then one last time, let me put this up. I feel sorry, guys. Right, this is where I needed you guys in class, right, to correct me. This should have said R. So we're okay for this lesson, and we really didn't use it in 8.2 part 2A. Oh my goodness. But I will send out, I'll try to help you out on the email as well. All right, so we're done with 8.2. 8.2, and this was for all for April 6th.